Ladies and gentlemen, what's up? Here we go. Part 2, video number 2 of section 7. And so far, we've talked about 5 Pythagorean triples. Can you name them? Here we go. 3, 4, 5. 5, 12, 13. 7, 24, 25. 8, 15, 17. And 9, 40, 41. Yeah, go me. Did you know them? You should. You need to memorize them. Memorize, memorize. And then we talked about another one. Wasn't a Pythagorean triple, but it was a special right triangle, a 30, 60, 90 triangle. In this video, I'm going to show you one more special right triangle that deals with angles, not side lengths. So forget the triples we just talked about. We're going 30, 60, 90 triangle mentality. Are you ready? Here we go. What's the essential question? The essential question is this. In section 9.7, part 2, the essential question, how do you find the side lengths of a 45, 45, 90 triangle? That's right. The first video in this section was 30, 60, 90. Remember, 30, 60, 90 had nothing to do with side lengths. Again, it has to do with angles. Same thing with 45, 45, 90. And here we go. Into your notes. It is Theorem 73. It is a 45, 45, 90 triangle theorem that says this. In a triangle whose angles have these measure of 45, 45, 90. The lengths of the sides opposite these angles can be represented by. Now, if you remember, 30, 60, 90 triangle was x root 3, and 2x. When a 45, 45, 90 triangle, it's x, and x root 2. So if you haven't already written this theorem in your notes, do so, but then accompany it with this picture. So you got a 45, 45, 90 triangle. According to this theorem, as it says, across my 45-degree angle, we're going to represent that with x. Across my other 45-degree angle, we also represent that with x. And by the way, should make complete sense. Why? Because this angle 45 and this angle 45 are equal. So therefore, the picture thing, angles imply sides, would mean that side is equal to that side. So this x and this x better be the same thing. We're talking about an isosceles right triangle. Word that. Yeah. So therefore, I can say then, well, hold on. The 45, 45, and the 90, respectively here, across from the 90 is x root 2. So it takes some memorization, whether this is a 45, 45, 90, 30, 60, 90, or the triples. You need to memorize these particular ratios. And now we're going to apply them. So how does this work? Well, guess what? The goal, as a little man down here, that's the little smiley face dude that looks like he's in pain because he just headed the soccer ball, whatever. He's telling you the goal. It's the same exact thing as what it was for 30, 60, 90. Find x. And as soon as you find x, people, bingo, you're done. So, for example, in this picture up here, if I found x, I don't know, to be 5, just make it up, that means this one here would be 5 immediately because it's equal to this side. And the hypotenuse would be 5 square root of 2. And you'd be done. It is that simple. Just find what x is and then plug it into the ratio, the proportion, whatever, and you're done. So let's do a couple examples. Here we go. Let me get rid of this. Get the next picture. So draw this in your notes as an example. 45, 45, 90, and let's say that one leg length is 6. Well, let's find the other two side lengths. How do we do it? According to my 45, 45, 90 triangle theorem, across from the 45 is what x is. Sweet, so that's going to be x. Across my other 45, that's what x is. Sweet. Across to my 90, according to the theorem, is x root 2. And my goal, as the little man down here again in the right corner is saying, hey, find x. You got it, dude. You can do it. Okay. I don't know if that's how he sounds, but whatever. So, wait. I got it. I already found x. It's done. In this simple little equation, just like I kind of set up with the 30, 60, 90 triangle theorem, I have my x already. So, therefore, this side over here would be 6. There's the other leg. And this side here, all I do is take the 6 and plug it in there for x. So, I get 6 root 2. Ladies and gentlemen, you're done. There's your answers. It is truly that simple. So what happens if I do this? What happens if I would take this particular 6 now and slide it over here? Now I have to find the other two side lengths. Oh, okay, well I can do that. So let's find the other two side lengths. And this means across my 45, 45 degree angle is x. Across from this other 45-degree angle is x. Across my 90-degree angle is x root 2. Oh, wait. Uh-oh. Did you see it? You probably already did. It's the same exact question as what I just showed you. It's no different. No matter where the 6 is, no matter what leg, it's going to come out to be the same answer because I already got x. So that's 6. So this is 6, and this is 6 root 2. And we're done. Awesome. So they go hand in hand. No matter, again, if the 6 starts here on this leg, or if the 6 starts there on that leg. Forgive me, it's a little late. Anyways, but here comes the difference. What happens if I move that 6 up here? Now, we got a little bit more work ahead of us, and you'll see why. But the work still is exactly the same, because I'm going to do this. Apply the 45-45-90 triangle theorem. That means across my 45-degree angle, that's x. Across my other one, that's x. Across from my 90, here comes your equation, because I'm already given this side to be 6. According to the theorem, that's supposed to be x root 2. So my goal, again, according to this little dude down here in the right corner, is to solve for x. Well, how do I do that? Well, I have x root 2. All of that equals 6. So I got to solve it for x. Well, how do I get rid of this multiplication over 2? Exactly like I did with the 30-60-90 triangle theorem. I'd have to divide by what I'm multiplying by. I need to get x by itself, so I divide by root 2 here, and I divide by root 2 here. What I do to one side of an equation, I got to do to the other side. So that's cool. So what happens then? Well, these guys cancel each other out, and I'm left with x. Awesome. So I have x equals 6 root 2. But wait a minute. I can't leave a root 2 in the denominator. You knew that. So I have to rationalize it. I have to multiply by that funky looking 1. I'm going to go root 2 over root 2. Why am I doing root 2 again? Well, the simple thing I told you. I just multiply by whatever's down here. Just duplicate it. Because when you duplicate it, it's going to pretty much get rid of that radical. And you'll see why. Root 2 times root 2 is the same thing as square root of 4. Lovely. On the top, the numerator, 6 times square root of 2 just stays 6 to square root of 2. I can simplify this square root of 4 a little bit more, so this whole thing then is going to equal 6 root 2 stays the same in the numerator. This guy goes to a 2, and now I can cross a couple things off. I can reduce the thing out of jail, and the thing out of jail, I can reduce that. So this thing right here, whole thing goes down to 3 root 2. Now, why did I do all that work? Again, my little man down here in the right corner is saying you got to find x. We just did. Remember, we canceled all this stuff. These guys are going over here to the left, and I'm just left with x. So technically, guys, x is equal to 3 root 2. Okay, so what? But wait, remember what we're trying to find. We were originally given up here in the left triangle that guy right there was already 6. I was looking for the other two side lengths, and I found x to be 3 root 2, and there's your answer. So this side is 3 root 2. I know, it's cool. I know, that's cool. That side's 3 root 2, and this side is 3 root 2. So there, ladies and gentlemen, are your two answers. I love it, man. So 45-45-90 triangle, 30-60-90 triangle, very similar in method. But you got to make sure you go back and study and memorize and remember 45-45-90 is x root 2. 30-60-90 is x root 3, and 2x. See you in class. It's going to be fun using these. Later. Peace.